All right, so here we have piecewise defined functions. We're going to make separate graphs and we'll put the pieces together. So let's get a graph of y equal x cubed. X cubed looks like this. The part of the graph that I want is when x's are are smaller than or equal to 1. So here's 1, so I want this part of the graph. So I'm going to put it over here in my solution graph. So here's the point x equal 1. I know that corresponds to the y equal 1, so this is the part of the graph, and it equals at that point. All right, so now let's graph this 1 over x cubed. It looks like 1 over x. And what part of that graph do I want? I want when x's are bigger than 1. So here's 1. And I know that would be at the y value of 1. I don't include 1, so I pick that up and put it over here. So that's at the point 1, so it's included with the other graph. So I don't put an open circle on top of a closed circle. The closed circle wins. It's included. So this is my solution graph. Well, let's try another one. So here I have the graph of y equal 1 over x. Looks like this and this. And so what part of this graph do I want? I want when x's are smaller than 0. So all of that. So I'm going to bring it over here and put it in part of my solution graph. Now I'm looking at the graph of y equal 4. So I know that looks like this at the y value of 4. And I want when x's are bigger than or equal to 0. So here and on out. So here and on out. So this is the solution graph. All right, so some things that we know that I presented to you before. So it was a fact that I told you needed to know that this is true. So if I'm looking to graph the square root of x squared, that's like saying graph absolute value of x. Absolute value of x looks like this. So what part of this graph do I want? I want when the x's are smaller than -2. So pick that up and on out, and I know that's at the y value of 2. So let me bring it over here to put it on my solution graph. All right, so then this, I'm looking at y equal x squared, which I know is a nice parabola. And what part of that graph do I want? I want when the x's are bigger than -2, including -2. So like this. So now what's the y value on the function? That would give me the y value of 4. So this one was at 2, and so now I'm at the -2 value. I'm going to have a y value of 4, and then I'm going to come down to the origin and move up here. So this is my solution graph. At the end, we should be able to draw a vertical line any point in the graph and have it touch at only one point, because this is a function. So the functions pass the vertical line test. All right, so let's put this graph together. So I have x minus 2 over the absolute value of x minus 2. So this is that one I call that graph. So at x equal 2, that's where it's not defined because I cannot use 2. So if I put in 3, I get a y value of 1. So it's y up here at y equal 1 all the way up to 2. And then if I put in numbers like 0 or -1, I get y values of -1. So this is the graph without x equal 2. So then to do this other part here, this says use y equal 3 when x is 2. So when x is 2, I'm going to pick up this point, x equal 2, y equal 3, right there. So this passes the vertical line test. This is the solution graph.